shooting it, and the camera got sucked in, and he was like, no, I'm looking at the camera. What do you mean? Run now. I'm like, why are you doing this? He got sucked into the fire tornado. Did he die? Yeah. It wasn't really bad. The storm. I highly recommend watching it if you're laughing and be like, wow, that's really not how that works. The Sharknado. Into the storm. It's like fire. It was on Pomax. Pomax. Yeah. We used to call it Pomax, but now it's a Pomax. What's the tarantula one where it's like earthquake? There's a spider one, I swear.
Why did the Rice Krispie treat that you bought at 2 weeks?
We're on 8.1. We're going to do 7, but 8 is more heavily weighted on the AP test than 7. And I think we're going to finish everything, but in case we don't, I want to get the stuff that's like more on there first, or less on there. Part of this lesson is actually review. I'm going to do it a little different than his like presentation. We've done this, average rate of change. You can put this as average slope. You can call it the slope between the endpoints. It's basically just y2 minus y1 over x2 minus x1. These are all just different ways to say the same thing. So I'm going to give you an example and see how that goes. Try that. There's 3 different things. We're going to do average, rate of change, mean value theorem we're going to review, and then we're going to do average value, which is new. So 2 things are review, and 1 thing's new, but they're all like easily confused with each other, so that's why they're all kind of in the same lesson. So I'll write down those notes for average rate of change, and then I want you to try this problem. Until it happened to you, then you would not think it was funny. I would think it was funny until I got hit with a stream of water. Well, like, you might catch like a stray too, like you didn't get something wrong. The person next to you got sprayed.
At least I have glasses. Someone in front of you got sprayed, or behind you got sprayed. It has to go over you.
Yeah.
Could you like angle though?
Like if I was shooting Nate or Riley, it was just trouble.
Drenched. Super soggy.
Try the problem. Stop saying things like super soggy and try the problem.
Did you?
Yeah. There you go.
What's your answer? Wrong.
That's right.
That's the problem.
Are we good? Oh, okay. I was like waiting, but so this is just basically you've got 2 comma something and 4 comma something. So if you plug in.
Yes.
You get those 2 points, and you're just finding the slope between those 2 points. So 12 over 2, which would be 6. So now I want you to try numbers. These are like a little tougher because you have to use the calculator for it. So this is more of a calculator challenge, I would say, than calculus prep. But number 7 and 8 in the homework are also rate of change. So we're gonna do like 3 sections. Like here's this, do a couple of these, here's this, do a couple of these, here's this. Should I erase the formula because I want to have that down somewhere? Ethan, you got it? Okay, everybody's good? Just because I want to put my calculator up there. So again, basically you've got 1 comma 1 and 3 comma 1, and you've got to figure out the 1. So I would graph this, like put that in my y equals, and then do, I think it's F5 value, and then type in whatever let's say 8 is no calculator. 7's calculator, 8's no calculator. You guys need more practice on like -1 squared than you do on like take derivatives. What? Yes.
I would have left it completely unexpanded.
But you guys should see like his answers on this test. Like the one that remember on the first gateway when C was I think it was -46. Zach's was like
Yeah.
He asked it like 3 times if it was a
it was like something like that. Was his answer, which is not wrong.
Well, I want to make this. There was some multiplication of fractions in
If
there.
there was fractions.
I did not.
I got scared.
I didn't want to mess with it at all. So I was like, okay.
Oh yeah, there was
Because I saw you working it out on your calculator when you were grading it. Because you just had it as C equals 47 on your sheet.
Yeah, because I was like, oh, I have to actually perform these 15 calculations that he put there for me.
I halfway did all the problems.
I mean, the opposite of that is some people trying to simplify and screwed up and cost themselves points. So it's smarter to not simplify. So I think this comes out to like -2.52.
Yeah.
And then this one's 0, right? So you go -2.52 minus 0 over 3 minus 1. So it's like -1.26. Your answer? Do we agree? Questions? Are we getting it? Okay. I think I flipped it too.
Yeah, you did.
This should be 1 minute. Why don't you say something? Because I did 2.52. -2.52 minus 0, so I have to go the same direction. So it's positive 1.26. Thank you. Is that okay then? Like we're good getting the value in our calculator? Everyone's okay with that part? Okay. And then 8 we can do without the calculator. So if I plug in -1, I'll get -1 here. -2, so that's -3. -3 plus 2 is -1. And if I plug in 1, I'll get 1 minus 2 plus 2, which is 1. So my slope would be 1 minus -1 over 1 minus -1, which is 2 over 2, which is 1. Are those two okay? Questions on 7 or 8? Okay. Mean value theorem. This is review, but we didn't spend a ton of time on it. So the mean value theorem says that at some point the average, or let's say the slope between the endpoints equals the instantaneous slope. Slope. So I don't know if you guys remember, but we drew like 2 dots up here, and I had you guys come up and draw on the board. And I go on like back and forth. But if I did something like that, the slope between the endpoints is this. And the mean value theorem says at least one other spot, you're going to have the same slope. So like in this one, I have 2, it'd be there and there. But the slope between the endpoints is like the dotted line, and then say the derivative, like your surfboard, would match up at those 2 at some spot. So let's say, so we'll keep it simple, y equals x squared from, let's do 2 to 4 again, just the same thing. Find C to satisfy the mean value theorem. That may or may not be enough for you to get started. Oh, wait a second. So I want you to try that, but if you're stuck, tell me and I'll work through it. But just start squirting. you're talking about this work on less punishment for misbehavior. It's not misbehavior, not maybe it's just I'm just joking.
Oh yeah.
People come in. Like you know, a packer has to go open his door and he locks it. Imagine if every time you went to unlock it, you just come in like, coming. Like,
How so together you'd sit right there, and every time he'd ask some stupid question,
these questions aren't stupid. I swear.
well, sometimes they're like not on what we're talking about. He'd be like, on number 4, yeah, we're working on number 2 right now.
Okay. So f of b minus f of a over b minus a, that's just your slope, just regular slope. So just like before, we'll have like 2 comma 4 and 4 comma 16. So 16 minus 4 over 4 minus 2. 12 over 2 is 6. So that's this is 6. And you want to set that equal to the derivative. So what's the derivative of my equation? It's 2x. And then we'll find out that x equals 3 if I divide that, which fits right in between 2 and 4 and makes sense. It doesn't have to be right in the middle, but it should be in between those two numbers somewhere. Like if I got negative 3, I probably did something wrong. Or I guess it could be like, yeah, I bet it's something wrong. Is that familiar? Question on that? Can I help with this anymore? Those are useless. Everyone just stares at me. Try number 9. So on the homework, 9 and 10 are the average rate of change. Number 9 is a no calculator. Number 10, you can use a calculator.
Yes.
So the new stuff is similar to a couple old things we did, so we'll review those 2 things first. And here, I didn't start with this. What? The square root? Then use chain rule. Yeah? Okay. Well, that comes out nice, doesn't it? Because you get 5 and 3, so it's actually not bad. You don't need your calculator for that one either. But it's in the calculator okay section. It's already been determined. So. Just rewrite it like I did up there. So now chain rule. So bring down the 1 half. Leave the little guy alone. Reduce the power by 1. And then multiply by the derivative of the little guy. That helped. Just didn't want to give you an indication. Just got out. Oh, that was kind of nice too. There's the first one. So here's your 2 points. The slope is very nice. It comes out to 0, so then you just take the derivative of 7 equal pretty straightforward to solve. Oh, wait a second. Questions on that? So it's like 0, 3, 4, 3. So your parabola must go like this, and then at 2, we match the slope. So this must be 2, 0. It's right in between. Wait, it doesn't have to be 0. It's 2, something. Alright, so for this one, if I plug -2 in, I get 25. The square root of 25 is 5. If I plug in 0, I get 9. The square root of 9 is 3. So then 5 minus 3 over -2 minus 0. So 2 over -2. So my slope comes out to be -1. Is that part okay for 10? Then I gotta set the derivative equal to that slope. So the derivative, first I'm going to rewrite it to the 1/2 power, and then I use chain rule. So bring down the 1/2, reduce the power by 1, multiply by the derivative of the inside, and I want that to equal -1. So I multiply these two together. I have -4 times 9 minus 8x to the -1/2 equals -1. I think I would divide both sides by -4 here. Which will give me 9 minus x squared to the -1/2 equals 1/4. With me? No, it is just 8x. Then I would raise both sides to the -2nd power. So you've got to cancel out this power. So a power to a power you multiply. So if I multiply these two powers together, I get 1. And then 1/4 to the -2nd. So forget the negative signs there. What's 1/4 squared? So square the top, square the bottom. 1/16, right? But what does the negative do? Flips it. So this goes out to 16. And that is just like a normal algebra equation. So I have -8x equals 7. I subtract 9 for both sides. And divide by. What did I do wrong? What's not between 0 and 4? Oh, yeah. So it's this. Okay, yeah, that does fit there. Thank you. Question on that one. Okay. So those are like the ones we've seen before. So the average value is new. Try to explain it a couple different ways. One of them works best with like a negative. Well, I have like a good analogy, but it's not quite good enough. But we're gonna try it. So let's say. I think it'd be wise to wait because I'm not sure what I'm doing quite yet. All right, let's say I've got that, and this is a pool with water in it. So average value is the same idea as average. So average y value. The same idea as average height, which is the same idea as, I'm going to say, average depth of the pool. So those are all the same thing. I'll show you the formula in a second. I'm trying to explain the concept. So you're going to put in a pool. You call someone over to build your pool, and they build this like circle bottom, and they put a bunch of water in it, and they're like, "Here's your pool." You say, wait a minute, I didn't make this clear, but I actually wanted a flat bottom to my pool, like a perfectly flat bottom. So something like this. But I want the exact same amount of water in it. So then when the question is, what would this depth have to be so that if it were flat all the way across instead of curved, then we would hold the exact same amount of water. So I'm trying to find like the average depth. Another way to think of it is the average Y value. So like that's a Y value, that's a Y value, that's a Y value, Y value, Y value, Y value, Y value, all the way across. Add them all up, divide by how many there are. So we're trying to find like the average value. So it's the same idea as average height. You got a height at this spot, a height at this spot, which is just the Y value. Take the average height at all of those spots, or take the height at all those spots and average them together. So those are all kind of the same way of explaining. Does that make some sense what we're looking for? Alright, so the average value is the integral divided by the length. So let's say I have, my problem, I guess. Is there a blank page there?
There's a section.
Oh, okay. So this is the formula that we're going to use. Then I'm just going to like do one. And then have you guys try it out. So we'll use the same thing, y equals x squared from 2 to 4. So if I were to graph that, it looks something like this. And I want to know the average value. So what, again, just to describe what we're doing, there's y values all along this road. And if I were to find all of those y values and average them together, I'm looking for what is that y value. Or if you think about it, it's weird, it's not really the depth of the pool because it's like above ground, but like you poured a bunch of beans into something this shape. And you want to know, well, I don't like that curvy top on my beans because they're going to fall out. I want a flat top on my beans, but I want it to have the same amount of beans. So where would that be? So, it'd be somewhere around there where I'd have a rectangle that has the same exact area as my goofy shape. Does that make sense? So the average value says you find the integral from 2 to 4 of x squared, and you divide it by the length, which is just the difference between those two. Or some people prefer, I'm going to multiply by like 1 over the length. Like those are the same thing, right? You can do either one you want. The most common mistake, especially because you start doing these with your calculator sometimes, is you'll do this, whether you do it by hand or type it in, you'll get an answer, and then you'll write that answer down. Instead of remembering to divide by the length, or multiply by the reciprocal of the length, like whichever one you decide to do. But go ahead and type this, see if you can do that in your calculator. Yeah, you're gonna put like this. So it's F3 calc and then integrate. And then you go x squared, comma. This is the part where you tell me what goes after the comma. Comma x and then 2 and 4. I think, isn't that the right order? Yeah, we'll find out. Yeah. And then it should pop up and tell you. Like it shows you when you typed in, so it shows me the integral of 2 to 4 from 2 to 4 of x squared. Which I got 18.666.
I got 9.333.
Okay, you're a step ahead. I'm like demonstrating the mistake because I'm not done. So when I typed that in, it gave me 18 and 2/3, 18.66666. And that's a super common mistake because people will write down that. But you have to multiply it by half or divide by 2. So now it's 9 and 1/3 or 28/3. So those are both right. Did you figure out what you got? 20. Oh, then you're good. Okay. probably a